periodic table. It's the only part of the history of the entire course that we have to talk about. And then we're going to talk about some trends. Now, you have 2 homework assignments that you have to do tonight. My 2 sophomores. You guys have to get that to me tomorrow. Whether it's before the ACT, pre-ACT, after the pre-ACT, I don't care. But it's sometime between when you get to school tomorrow and when you leave school tomorrow, you need to drop off your homework assignment to me. The rest of you that are here tomorrow need to make sure you hand it to me at the beginning of class. If you choose not to bring it to me tomorrow, you take 2 0 quiz grades. I'm grading this for accuracy, not for participation. Okay? Now, if you don't bring it to me at all, you get 2 zeros. They are not eligible to be made up. So if you have a brain fart and you leave your homework on the bed, on the desk, the dog chews it up. You took 2 zeros for homework for tomorrow. That it's not homework grade, they're 2 quiz grades. Okay?
Question.
Put reminders in your phone.
Question.
Yes, ma'am.
What if you don't turn it into hands? What if you take a picture of it in case something happens and email me what you've done?
I will assume you cheated and copied someone else.
Oh, that's what? Okay. Okay.
Now, some of you are going to do that anyways. I can't fix that. Some of y'all are just stupid and will hand your homework to other people. Okay? I can't fix that either. When I was in high school, I worked hard. I didn't give my homework to other people. I was a little smart, some of y'all. All right? I can't fix that stuff. Y'all are in high school. I understand peer pressure. And some of y'all are like my dog. She has a group. God bless her. I'm serious. There are about 3 or 4 of them. Take pictures of their homework and swap it out. I did the English homework. Somebody else did the AP Calculus homework. Somebody else did the APUSH homework. They swapped their homework left and right. Some of y'all will do that. Well, I'm slightly appalled. However, I'm not in high school anymore, and I don't have to deal with that. Now, it is what it is. Now, you have 2 homework assignments that are due tomorrow.
Are they easy? Like, are they based on what we do today? Or are they?
Sort of. One you should have pretty good knowledge of and be able to do pretty easily. One, you're going to need some resources, and you may use the internet.
Okay. How long do you think it'll take for us to do that?
Less than an hour.
That is
Less than an hour.
Okay, that doesn't take me a that'll take me a whole night. I can't
It should not take you a whole night. If it does, there's something seriously wrong.
Yeah.
Now, moving on. I'm just telling you not to forget. The people who are absent will have an alternate assignment. They probably won't do it anyways. Now, that's just the reality. If they come in later, like Almaji, who would probably do the assignment, feel free if you see her to come by and pick it up. For those of you who like titles for your notes. Now, periodic table. My O got a little jacked up. Now, we're going to talk about the periodic table for, I don't know, what's today? Tuesday, Wednesday, probably finish it early Thursday since we have so long tomorrow. And then we're going to do bonding. We will not be able to test before Thanksgiving. So, I know, so you will not have to worry about a test for me before Thanksgiving because I know a lot of people will probably try to test before Thanksgiving.
I would rather that.
Well, you're going to have to remember until after Thanksgiving. All right? So we will test sometime the week after Thanksgiving on the periodic table and bonding. Now, bonding is not that bad. The reason people struggle is you have to learn the geometries and you have to memorize that part. And people are like, oh my God, I can't remember that stuff this fall. Yes, you can. Well, get some flashcards. But use one of the apps on your phone and just learn the geometries. It's not that difficult. Okay? Now, the periodic table. First of all, there's a Russian scientist by the name of Dmitry Mendeleev. And he is one of the major scientists that you are expected to know for the state test. Okay? Now, I would hope by the name Dmitry Mendeleev you can remember the dude's Russian, but if you can't, write it down.
We have to know it.
I sincerely doubt it, but it's never a bad idea to remember some basic facts. Now, Dmitry Mendeleev was working on a table. At that time, it wasn't necessarily called a periodic table. He was just working on a table of elements. Okay? Nope. Now, when he was working on this table of elements, he was trying to organize the information that they knew. Okay? He placed all the known information on cards. Okay? Now, I tend to call them index cards because that's what we call them today. Back in the time that Dmitri Mendeleev was working in the 1800s, would we necessarily have called them index cards at that time? I do not know what kind of information and cards they had in the 1800s, so they may not have called them index cards at that point in time. However, you guys can all visualize an index card. So visualize an index card. He's writing down the information known about elements at that time. There was an Italian scientist by the name of Stanislao Cannizzaro who had discovered atomic masses. So he wrote down atomic masses. He wrote down their densities. He wrote down their melting points, their boiling points. The information he knew about the elements, he wrote down on these cards. Okay? Now, he attempted to arrange them in some type of order. When he noticed two patterns. Okay? He attempted to arrange them in some type of order when he noticed two patterns. Everybody caught up? Okay. Got it now?
I do.
Okay. All right. So what are these two patterns I'm talking about? All right. Number one, the elements increased in atomic mass, but not in all places. And number two, elements had similar properties. Now, because we've worked with the periodic table before in other science classes, what did he do with the elements that had similar properties? He what? That's right. He put those in groups. Now, so as Mendeleev is working on this periodic table, he's noticed that elements increase in atomic mass, but not in all places. He's noticed that elements have similar properties, and he's put these in groups. So now he's got a problem. He's like, huh, what do I do? Do I leave these based on similar properties, or do I rearrange them based on masses? So he's got selenium and bromine, and then he's got tellurium and iodine. And tellurium has an atomic mass of 127.6, and iodine has a mass of 126.9. Now, according to what he knows, these have similar properties. These have similar properties. But the atomic mass goes down. So the question Mendeleev has is, does he flip the elements? Right? That's Mendeleev's quandary. What does he choose to do? Does he leave tellurium and iodine where they are based on their similar properties, or does he choose to flip them based on his first pattern of mass? What do you think Mendeleev chooses? He left them. Okay? He left them. Now, why on earth are we talking about a scientist who can't explain the periodic table correctly?
Someone else used his crappy work.
Well, he did something else besides this crappy work. He is significant to the process, but we need to talk about what is significant about his process. Huh? I can't hear all of what you said, Lolly.
I heard that alone. Yeah.
Say it loud enough I can hear you.
Had you not been to just
What?
Did you tell your mom about that?
No, I don't.
We told Brooke about it.
What did Brooke say?
She was like, I kept saying it for so long and no one corrected me. And then one day Miss Wallace asked me what I was talking about.
I had no idea that that's where that word came from for the longest time.
You just thought she was talking about something random.
I did. I had no idea that's where she got it from. I thought she made up a word just to be irritating. All right. So why on earth do we give this guy credit, and why are we still talking about him 150 years later? All right. Mendeleev, along with what he did, predicted the existence of elements not yet discovered, and left places for them in his periodic table. Okay? So, remember, this is a guy working with index cards spread out on a table with information written on pieces of paper. And he's saying, based on what I know, there have to be other elements out there that will be discovered someday. So I'm going to leave holes in my table for them. Not only did he leave holes in the table, he predicted their properties. All right, their melting points, their boiling points, their density, their atomic mass. Okay, the things that he knew about the other elements, he predicted about the elements that had not been discovered. Now, he didn't have these elements or the materials. He couldn't melt them. He couldn't boil them. He couldn't find their mass and volume to find their density. He did this based on other index cards and pieces of paper. He said they will be discovered, and this is what their atomic mass will be. Now, was he correct?
No.
Yes. This is why we're still talking about Mendeleev. All of this is correct. The fact that he can't explain why this went down is irrelevant compared to all of this was correct.
So he was like, correct.
Pretty doggone close. Okay?
How? So all we know
I'll show you.
is he's Russian. I don't think Russian.
Okay, like, and question, are they still discovering things with beer?
Huh?
They're still discovering things with beer, aren't they? Are we
The
done?
last thing.
This entire row has been filled at this point. So all of these elements have been discovered. So all of these at one time had names of, when I first started teaching, see how up here this one says UUO, UUS, and UUP?
Yeah.
All of these said UU something all the way over here to like 106, 107. And they've all been officially named in the 28 years I've been teaching. And these that say UUT, UUP, UUS, and UUO have all now officially been named, and they don't say those anymore. Those were unofficially named. I forget what their names are now, but they're all officially named. There are none of them that are now not officially named.
But if you find something else, where are you?
They would have to have an 8th row. So there'd be an 8th period on the periodic table. All of those are radioactive, and they all come from radioactive decay from other elements on the periodic table. Doesn't have to be. Y'all should take the anatomy or forensics class that Ms. Wicker's teaching if you don't want an AP class.
I've already taken it out. I'll take forensics. It looks fun. I guess.
Yeah, I'm done.
Yeah, you've done fine. There it goes. Now, don't ask me what this says. I do not speak Russian. I don't read Russian or anything else. Now, remember, this was also done 150 years ago. It does not look anything like the modern periodic table. All right? Yes, this was his first attempt at the periodic table. Now, if you look, the question marks that are here are places that he left for elements to be discovered. Okay? All of the question marks are things that he said would be discovered someday. These are his prehistoric groupings of elements. Now, that's not the reason that I pulled this out. The reason that I pulled this out is to show you his predictions. Now, Eka-aluminum is the name he gave for his prediction. So these are the things that he predicted for Eka-aluminum. All right? That is what was discovered in 1875. Eka-boron is what he called scandium. This is what was discovered in 1879.
What is scandium? It sounds disgusting.
It's a metal.
It
It sounds like
Scandinavian.
Thank you.
It's just a silver metal.
Yeah.
And then ecosilicon is what germanium is called. It was discovered in 1886, and those are the numbers. Now, if you look at what he predicted and what they turned out to be, he's not terribly far off for somebody who worked with sheets of paper.
So did they just change the oxide formula to a GE? Because I meant like, oh, why did they change it?
Well, yeah, remember, he didn't have an element symbol or a name. So he just used an E because they didn't have a symbol at that point in time. And so that was the symbol that it was discovered as, so they substituted in the real symbol at that point. So this is, yes, he basically had it right, which is why we're still talking about Mendeleev 150 years later.
Well, question, did they just make up symbols?
They use Latin names. A lot of the symbols are based on planets. They're based on people. They're based on locations.
What planet? What person?
Like plutonium, Uranus.
Oh.
Some
those
are-
the obvious ones.
Right. Some of them are like, if you look down at the bottom, some of them here are named after Rutherford, who discovered the nucleus of the atom, which we don't teach anymore in chemistry. Miternum is down here. He worked on the atomic bomb and nuclear chemistry. Marie Curie, have y'all ever heard of her?
Yeah.
All right, she's up here somewhere. Curium, CU. She's up here somewhere.
It's 96.
96, thank you. Polonium is the element that Marie Curie discovered. That's named after Poland, her homeland. So it sort of varies. Copper is named after the Latin name cuprum. Ferrum is named after the Latin name for iron, Fe, ferrum. So it runs the gamut after where the names come from.
Who's Mosley?
Who's Mosley? We're getting ready to talk about that. What? Say what?
95.
What about 95? Americium?
It sounds like they just made those names.
You could probably say American and sound like we're from West Davidson.
Neptunium.
Neptunium is named after Neptune.
Sounds so made up.
I did not know.
So I said some of them are after people, some of them are after other things. All right. So back to where we were. Let's get rid of that and finish Mendeleev. All right. So Mendeleev never could explain the problem. All right. So Mendeleev could never explain why mass decreased in a few areas. He left the elements grouped by similar properties. So if I ask you about Mendeleev, what would be more important? You telling me about mass or you telling me about similar properties? Similar properties. Even though he talked about mass, mass is not the key to Mendeleev. Now, Mosley, who Anthony saw below the periodic table, came along a few years later. And I can never remember if this guy's name is John or Henry.
American.
I'm going to say yes to that, but I can't. He could be English. I think he's English.
It's probably John.
Henry.
Hey,
Henry.
close enough.
I'm pretty sure he's English. All right. Henry Mosley came along. I think he's got another E in there. All right. Henry Mosley came along later, and he discovered each element increases by 1 proton. So what did he discover? Yes. Henry Moseley discovered the atomic number. If every element increases by 1 proton, he discovered atomic number. So, catch up with me and we'll go back and see if Mendeleev did the right thing with his elements. All right, so if we go back and we look at this, tellurium's atomic number is 52 and iodine is 53. Did he leave them in the right order? Yes. Yeah, he did. Okay, which is why we still talk about Mendeleev to this day. Okay, now, what are the 3 new sections that have been added to the modern periodic table? All of these elements have been discovered in the 1900s. Yep. All right, the lanthanides, the actinides. One more. Yep.
Oh. We didn't know what hydrogen was.
It's not a noble gas.
Or the other one was helium.
Yep. All right, so the lanthanides, just to give you another name you might see, are often called the rare earth elements, although they're not really that rare, so I don't know why we call them that. All right, but they're often referred to as the rare earth elements. The actinides are all radioactive. Every single one of the actinides are radioactive elements. And the noble gases used to be called the inert gases because none of those reacted. They've changed in the last 30 years to the noble gases because they've gotten krypton and xenon to react with fluorine. Yeah. Remember, the noble gases have 8 electrons. Do they want to react with anybody? No. And fluorine is the most reactive element on the periodic table, which we're getting ready to talk about. And so they got it to react with those 2 elements. But they've still never gotten helium, xenon, helium and neon to react with anybody. And argon. Argon hadn't either.
It looked like the whole world's trying to mess with some elements.
Well, that's why you have nuclear reactions to that.
I mean, I've been watching Criminal Minds lately, and everything's they've been using the bombs and.
That's why nuclear chemistry is what it is.
Yeah, it's weird they can do something so small.
If I make bombs, can I make a lot of money?
Huh?
If I make bombs, can I make a lot of money?
Not
illegally?
Not illegally.
Not illegally.
I'm sure that terrorists would pay you handsomely for your bombs.
Wow.
Okay? Just saying.
How do they test elements?
Huh? For the most part, it's in a controlled lab situation. All right. Everybody got what they need?
Sure.
Because now we need to talk about some trends.
Oh boy.
First one we know. I'm just going to add a little bit to it. You've already done the basics. And then the second one up there, boiling point, melting point, density, and hardness is just the opposite. And all 4 of those are the same trend. So that should be easy.
Let's go. Do we need to know
I wouldn't ask you anything that big.
What does krypton do to me?
Huh?
What does krypton do to me?
Krypton? I don't know. You can research and find out, but I don't know off the top of my head.
So I keep thinking.
It has nothing to do with Superman. Kryptonite is made up.
I know.
Alright, does everybody have what they need? Alright, reactivity is our first trend. Now, this is the section that I have more students who come in the next day and go, Ms. Wall, I don't get it. I know, I'm going to get a lot of that over the next couple days. Because the thing is, you have to do a little bit of work on your own here, and you actually have to study. Some of you won't have to, because you'll hear it, and you'll be like, okay, I got it. Okay? But if I ask you tomorrow, let's just say there's a quiz. There's not. But when we have a quiz, and the question says, which of the following is the most reactive? If you don't know the reactivity trend, can you possibly answer the question?
No.
Okay, for example, tomorrow we're going to do atomic radius. Okay, you have to know the atomic radius trend. Where on the periodic table are the elements the biggest and where are they the smallest? If you don't know where they're the biggest and where they're the smallest, can you figure it out? You have to learn that piece. I'm going to talk about it. I'm going to teach it. But at some point, you have to learn as they go this way, they get smaller.
I knew it.
As they go this way, they get bigger. Okay? If you don't know that, can you possibly figure out which of the four elements are the biggest and the smallest?
No.
Okay? That piece you have to do so that when you come in to take the quiz, you can do that. Okay? Now, the problem is there's 7 trends we're going to do when you add them all up. So there's essentially potentially 7 of those things you're going to have to know. I'm going to teach you some tricks with it to help you, but you got to learn some of that on your own instead of coming in and going, I don't get it. You didn't do any studying, but you still don't get it. Okay? Now, reactivity we know. We know the basics. So if I ask you, based on what you did on the test anyways, how many electrons are in group 1? Group 2? 13? 14? 15? 16? 17? And 18. Okay? You can all tell me who does not want to react with anybody, right? Who is that? Got it. All right, so we all know that this group right here is not reactive or stable. Now, I can say reactive and active at this point, and everybody knows what I mean, right? Okay. So we're going to stick to the metals for right now. I want to know who is the most reactive metals on the periodic table. Okay?
Do we rewrite this?
Completely your option. I'm just reviewing it at the moment. Okay. All right, so they're the most reactive metals. Now we want to branch out from what you know. Who is the next most reactive metals? 2. Okay. Where would we go from group 2? Talking metals. All right, let me ask this. Okay. Where are the metals? I didn't mean to stump y'all. Where are the metals? That's a better answer. Left of the staircase. So when I say where are the next most reactive metals, you need to stay where? Left of the staircase. Okay. So you said group 1 and then group 2. And then who'd be next after group 2? Where? Where's 3? Group 13. I like that answer so much better. Okay. So we're going to go with Chris's 1, 2, 13 here. All right. So instead of saying group 13, we're going to call all this down here the P block. Okay? This we're going to call the D block. Okay? We're going to lump all those elements together. So, we have for our trend, group 1 is the most reactive. Group 2 is the next most reactive, you said. And then Chris said group 13. Well, instead of it just being group 13, all of these P block metals are more reactive than the D block. Now, that means that group 1 is the most reactive, and the D block is the least reactive. Or you can think of it as the most stable of the what? What am I talking about here?
Metals.
I'm talking about metals. I am only talking about metals in this trend. Okay? I'm not talking about any non-metals. We're going to do them separately in a minute. Now, does the placement in the group matter? Do they get more reactive as you go up or down?
Down.
Yes. All right. As you go down the group, they get more reactive. So, for example, if you put sodium, which is in group 1 in a container, it will explode. Put it in a little water, kaboom. But if we go further down the group to potassium, would it be the same size explosion? No, it would be what? It'd be a bigger explosion because it's more reactive. No, I cannot have that as a high school teacher. However, some colleges still have that stuff. And if you take a college chemistry class, a lot of those professors will take a small sliver and let it bounce across the top of the water. Okay? I can't have it, sorry. Look it up online. I'm sure there's a YouTube video out there. Okay? Now, can we try a question? Okay, just get it wrong on the test. I'm good with that.
Yeah, because I have a question. Can we look this
I mean, I didn't know that.
I got lots of F's this quarter. I'm good with it. The queen of failing people this quarter.
Why?
Why? People don't come to school and don't make up their word. Last count in here, I had 9.
At me next time, bro.
You're not failing.
Not failing people, they're failing themselves. But in the moment, there's just a ton of them. And that was before we took the test. I didn't count it since we took the test. Although that should have helped some people. All right, everybody got it? All right, so if we do non-metals, okay? So if we look at the same table, okay, so I don't have to redraw it. Where would the most reactive non-metals be? Okay, because I'm going to label this as non-metals now. All right, let me start again. Whoops, wrong way. Where are non-metals at? Right at the stairs. Okay, so looking at that, where are the most reactive non-metals? Because I feel the need to draw this again, but I'm trying not to drive people crazy by drawing it. Okay, y'all are going to force me to draw this thing on the board, so it's right up here under my non-metals. Okay, my non-metals are where?
Oh, it's group 17, isn't it?
Oh.
Because Because you said that was the next.
Okay, we already said those are stable, so they're out of the running.
Is it group 17?
The non-metals are where?
To the right.
To the right of the staircase is where y'all keep telling me.
Yes.
Now, I keep getting answers of like 13 and 14.
But is it
It's
17?
Okay, change my color here.
It makes sense now.
All right, 17 is the most reactive. Why are they the most reactive again, since we seem to have forgotten?
Because they are the.
They are one electron away from,
Being in.
that's right, away from 8, which was an octet. Okay, they have 7. They will take that one electron from anyone who will give it to them. They're sort of desperate, okay? They're not picky out there. They'll take it from anybody. So group 17 is the most reactive. So what over here? Who was the most reactive over here? 1, because it only has to give away 1. It will give it to anybody who will take it, which is why it was the most reactive, right? So the flip side of that for non-metals is group 17 is the most reactive because it will give it away to anybody who wants it. It does. It wants to take it from anybody. Like group 1, please give me your electron. Please, please, please. Remember, group 1, group 17, they'd hose.
And that's only with non-metals.
Okay? Group 1 and group 17 love to form compounds. And they make stable compounds.
So it's like form.
Yes.
Oh.
All right? Yeah, they're the prostitutes on this table. All right? So who would be the next most reactive up here? That's right. All right?
So metals, it's the lower numbers, and then non-metals starts with the higher.
It's all about getting closer to 8. Who will lose the easiest and gain the easiest? Well, for electrons, they're not getting closer to God. Huh? Okay? Remember, this one has to gain 1. This one has to gain 2. So that's why they're more reactive. So when we talk about reactivity, group 17 is the most reactive. And then who? Group
16.
And then who?
13.
Now, y'all keep telling me group 13. Group 13, if we look up there at the table, look up there at the colored one. What does group 13 have mostly in it?
Group 18.
Look at group 13. What color is group 13?
It's mostly metals.
That's right. So should I include group 13 up here?
Not wrong.
No. And should I really include group 14 looking at the colors?
No.
I mean, you can.
You can. It has 1. But why don't we just stop at group 15?
Yeah, let's do that.
All right. Now, its reactivity. Does it get more reactive as we go down? This one gets more reactive as we go up. All right, so let's talk about who's most reactive in a group. Uh-huh. Don't tell me helium, it's in group 18 and they're not reactive.
We're going to go with fluorine because you already talked
That's
about
right.
reactive on the periodic
So look at your groups. You just told me that group 17 was the most reactive, right?
Yeah.
So you have fluorine, you have chlorine, you have bromine, and you have iodine. What happens as you go up? So who is the most reactive nonmetal?
Chlorine.
Fluorine. So who's the biggest hoe of the nonmetals? Okay? The biggest hoe of the nonmetals. It will react with anybody. Okay? So as you get closer to fluorine, it's more reactive. Now, we can do the same thing with the metals. So if we cruise back and we look at group 1, okay? What happens in the metals? Look at group 1. All the way, what happens? Up or down in the metals? Going down. So who's the biggest hoe in group 1? FR. Down here. Francium. Okay? Are you with me on that? Okay. Now, the last trend that we're doing today is boiling point, melting point, density, and hardness. Now, hardness, you probably talked about in earth science. You would have talked about the Mohs scale and how hard rocks are. We don't necessarily talk about the Mohs scale in chemistry class, except some metals are very hard and some are not. Like titanium is a metal that's very hard, and lead is a metal that's very soft. You can bend lead back and forth. Titanium, if you buy a titanium metal wedding band, some of you will one day buy a metal band for your wedding band. Some of you might like carbon. It's more like a black metal graphite. It's very attractive. Titanium is a nice, bright silver color. The downside of a titanium band, gentlemen, if you get married in your young 20s, you will probably not look like your young 20s and your 40s. It cannot be resized. Okay? It's not a resizable band. That metal is very sturdy, not resizable. So if you get fat, you're going to buy a new band.
They can't,
okay?
Like, add metal, like,
no, they can do lots of things. Titanium is not one of those. Guys, it's a word of the wise. So, when you talk hardness, some things are very soft. For example, gold is a very soft metal. That's why they sell it in various carats. 24 karat is incredibly soft. If you buy it in 24 karat, you slam your hand down on the counter, it's going to take the shape of the counter. Go ahead. All right, a lot of people buy 14 karat. 14 karat, again, it's going to be a little softer than 10 karat. 10 karat is a stronger, while they add different metals, it's to strengthen the gold. Now, that's what I mean when I say hardness. So boiling point, melting point, density, and hardness. We can talk about those characteristics of various metals based on their location on the periodic table. Now, these are for metals only. All right, so put that up here. Metals only. Okay, we cannot do this for nonmetals because nonmetals are solids, liquids, and gases. Okay, everybody good with that? Nonmetals are solids, liquids, and gases. Yeah. Metals are, with the exception of one, solids only. What's the exception? Mercury. Mercury can be a liquid at room temperature. Now you can turn mercury into a solid, but at room temperature and normal atmospheric pressure, it's a liquid. So all other metals are solids. We can have this conversation. So where on the periodic table would boiling point, melting point, density, and hardness be the greatest? Any ideas? Okay. Think about the way we did it here, using these sections. The P block, the D block, group 2, and group 1. Okay? Think about it in those sections. Where do you think the density or the hardness of the elements would be the greatest? P block, the D block, group 1, or group 2? D would be the greatest. Okay? The D block elements are always going to be the greatest in melting point, density, hardness, and everything else. They're going to be the strongest. All right, where next? P. P will be next.
We're just going to go backwards.
Exactly. All right, Diamond was listening to me earlier when I said it's what? What'd I say, Diamond?
I wasn't listening, I just guessed.
I'd have swore you said, somebody said it a minute ago, it's the opposite of what?
Oh, I did say that.
Yes, you did. It's the opposite of reactivity.
Oh, I did hear that.
All right, it's the opposite of reactivity. So it's not a new trend, it's just the opposite of reactivity. So you have to remember its opposite. Are you with me? Okay. All right, let's see if you are.
Wait, I'm not.
Wait, is that all for that week?
There's no up and down. You don't have to know. This is not the homework. This is just a quick sort. Let's see if you can do it.
That was the homework of the
You
day.
have.
No, I'm going to give you some directions on the homework, so I'm not spending a lot of time on this.
Okay.
Because I need you to know how to do the homework.
Can we have our periodic table up?
Yeah, I don't expect you to know where stuff is on the periodic table. What are your periodic tables out? If you can't find something, let me know and I'll still tell you where it's at. I fix Caroline's test grade before I forget. Did anybody else have openings? Because I handed them back today, so if you can hand them to me right now, I will not mark them late. Thanks, my dear.
What do you do if they're both like at the top?
Gotta choose one.
Okay, question.
Yep.
When you said element of the week reaction, do you mean like including group 18?
Yes.
Okay.
Count 9 today, is that what you have?
What do you mean by element with A? Is this going to be -3? Number 7?
Yes.
What does that mean?
-3 ion, -3 oxidation number.
Oh.
So when it comes down to it, should we go off like the group they're in, or if they're up or down? Like which one's more important?
Which question are you talking about?
2.
2?
Because we're going between chlorine and oxygen.
Group. right, we done? One more time. Where are we at? Oh, you're at number 6? All right, let me put these up. We're getting pretty close.
Oh, every time we're gonna go, yeah. Actually, in this way, it depends how many people. I mean, most people close, so.
All right, can we talk about what you came up with?
Yes.
All right, which metal is most reactive? All right, A. So when you look at it, you have group 1 is CS and D, Li is in group 1. So you got 2 in group 1, right? So what happens when you go down the group? It gets more reactive. That's why you pick CS. Is everybody okay with that?
Sure.
Yes?
Yes.
Okay. If you're not, tell me. I'll be glad to walk through it and put it up under the projector and talk about how to get it. Anybody need me to do that?
No.
Okay, I'll be glad to. They pay me to do that, you know. Number 2, which non-metal is most reactive? All right. First of all, do we get rid of C? Why do we get rid of C? It's a metal. C has to go because it's a metal. All right, that leaves you Cl, which is in group 17, N is in group 15, and O is in group 16. Which group is more reactive? 17, 16, or 15?
17.
That's why you pick 17 or A. Okay. Which element has the largest density?
CR.
All right, the D block, right? So that's why you pick C. Lowest boiling point is where?
So.
Group 1. Which element is in group 1? D and A, sodium. Which element is the least reactive?
Neon.
Group 18 is the least reactive. Do I have anything in group 18?
C.
Neon, C. All right, which element has the highest boiling point?
W.
W, that's tungsten. Tungsten's in the D block. All right, and number 7, the -3 ion just means the -3 oxidation number.
B.
So which group has a -3 oxidation number?
Group 15.
Group 15. So who's in group 15? Nitrogen. And the last one, which element has 3 outer shell electrons? Which group has 3 outer shell electrons? Group 13. So it should be aluminum. Questions about how to do that?
Wait, 7 is B?
7 is B as in boy.
And 8 was A.
And 8 is what? A. All right, let's talk homework. All right, the first one is usually the one I get everybody to do because it's easy. It's a little on the cheesy side. I cut down a lot of the cheese. It was worse. I got a lot of that. You'll see why when I read the instructions.
This is a lot. This is a lot.
You think this is bad? I use the next one. Alright, so you and your friends have been magically transported inside an 18-room castle built by the famous chemist Dmitri Mendeleev. Each room is entirely made of one of the elements of the first 3 periods of the periodic table. No element is repeated. Let me say that again. Each room is entirely made of one of the elements in the first 3 periods.
So from hydrogen to
Argon.
Argon. Okay? Hydrogen to argon.
period. You said
The
period.
first 3 periods. Okay?
Let me make sure I put.
First 3 periods. No element is repeated. Everybody hear me say that again. First three periods, no element is repeated. Each element will appear in the state, the solid, liquid, and gas it retains at room temperature. So if it's describing hydrogen, hydrogen you all know is a what? It's a gas. It will describe it as a gas. It's not going to suddenly materialize as a solid.
So we're not using it.
Huh?
Like if we.
Miss Wall,
Yes.
can you send Caroline Pyle to the office? She's signing out.
Yes.
Thank
You're
you.
welcome. Yeah, the other one is correct.
I'll take
that.
Huh?
Like, is it pretty self-explanatory?
I hope so. I'm here after school if you get stuck and need some directions.
Okay.
Okay?
Can you do the first class?
No, but I'm going to do the first one with you. All right? Now, you do not know where in the castle you've been transported. A holographic image of Mendeleev will accompany you on your journey. All right? So I said I cut down some of the cheese, which is not quite as bad as it used to be. It used to be like 4 paragraphs and stuff. All right? Now, you have clues to help you determine which room you're in. Now, the first one's pretty easy. All right? You suddenly materialize into a room made entirely of a shiny metallic solid. The room has been constructed of a lightweight, corrosion-resistant metal composed of atoms containing 3 valence electrons and 13 protons. Now, if they tell you you have 13 protons, that should tell you exactly which element you are. All right? It's the most abundant metal in the Earth's crust. What element are you? Then you write AL out there on the line. Okay? And then you do the remaining 17. All right? You got the first one?
No,
Fabulous.
I don't need to do nothing.
No. Now, the second one is where we need to spend our remaining time.
So what's this valence?
Valence is outer shell.
Oh, you back there.
Oh, it makes sense.
Okay. So I said, it's usually the one I get people to turn in. The second one that people go, nope, ain't doing this.
I mean,
Yes, little things that we do.
yeah.
Yes. You don't have to. I'll be happy to give you zeros. It's less trade.
I said you don't have to.
No, I don't mind giving zeros. I'm all about less paper straight. All right, so if you look at the second, all right, you're going to work on the first trend that we're doing tomorrow. Now, I've not taught the trend. I've just told you earlier in class you may use the internet. I fully expect you to. Okay? Now, the first part, you're drawing a graph. Everybody in here is probably, what math are you on? I'm guessing math 3 off the top of my head. Most of you have probably finished math. You're a math 3. What are you in?
Oh, I'm gonna take math 3.
Okay, so we're on pre-calc. Nobody in here is going to struggle drawing a graph, okay? Because the graph is like math 1 or middle school math, okay? So don't tell me that you can't do that. You should be able to answer the questions. Using the graph. However, I understand that most of you are going to be like, can't do it this long. Okay, I got you. I'm asking a lot. So I just told you you may use the what? Okay, so you can use the internet.
What if the internet doesn't provide?
If the internet doesn't provide, all these lovely brain cells you have in there
Or dying.
I have like 2.
that'll provide. Use the 2 you have. Okay? Now, turn your graph sideways. We're going to label it. Make sure everybody gets it. We'll start on the left. I'm so sorry.
It's so small.
I'm sorry. Now, I would love to tell you that this is big enough that you can count by ones, but it's not. So if you read the directions, it tells you along the x-axis that you need to label your atomic radius. So, atomic radius, let me back up here. Atomic radius needs to go along x. You do not have enough space to count 1 to 54 along your x-axis.
Yes, I do.
So, okay, go ahead. So, given you do not have 54 lines, what should you count by?
2.
Fabulous. Count by 2s, please.
Yes.
0. Do not forget the origin. And count 0 to 54 along your x-axis. Or at least, start and count 2 to 20 so you remember. Some of you may not have time to count from 0 to 54 before I stop.
1, 2,
2, 4, 6, 8, 10.
10.
Do not skip lines or it's the same as counting by ones. 4, 6, 8, 10. Huh? It's close. There's just not enough to count to 54. It's close. There's just not enough. I gave you fair warning. You not always not do it. Don't turn it in. It's a 0. Unless I got a grade. I've been very clear on that.
You can be a count 54, right?
Huh?
54, right?
Yes. All right. Stop there. You can finish counting later. All right, on your y-axis, you need to label atomic radius. Here, if you look at your numbers on the front side, the biggest atomic radius we have is what? Anybody see the biggest number we have in these atomic radius numbers? No, it's a 2. I think I see 2.16.
Oh.
I see a 2.16 billion.
This wall.
Hmm.
I thought you said atomic radius was on the x-axis.
No, atomic number is on the x-axis.
You
I said radius. Oh, it was number that I was using. Sorry, it should be radius.
So it's still.
It's on y. It's number on x.
So, this one.
I'm so.
Atomic number is here. If I say radius, I'm an atomic number. Radius is going here.
And so we have, I know it's to get 2.
Okay, so we have to get from 0 to 2.2-ish, let's say. So what would be a good number to go from 0 to 2.2?
0.1.
0.1 would be great. That's a good number. I like that. All right, so 0.1, 0.2, 0.3, 0.4. When we get to 0.9, what do we go to after 0.9?
1.
Just checking. Sometimes I get weird numbers after 0.9.
Have I been doing this wrong?
No, you haven't. I'm just checking, because sometimes I get really weird numbers after 0.9. So 1.0, okay, just checking. All right, you only have to go to 2.2. Now, just do a couple numbers so you know what you're doing. Because we need to talk about plotting the points here in our 3 minutes that are left. Does everybody have some points down so they'll remember what they are later? We got atomic number and then atomic radius. You fixed my mistake on the x-axis and wrote atomic number, right?
Yeah.
0.1. Atomic radius. Yeah, 0.1, 0.1, 0.2, 0.3, 0.4, and it's atomic radius on Y.
It's crooked, but we don't care.
I don't care if it's crooked.
Okay.
All right. Now, when you plot your numbers, is everybody okay with how to read the numbers on the front? So hydrogen would be 1 and 0.3. And you're going to have to estimate. Now, this is not a straight line. It will be an up, down, sort of jagged line. You have to connect the points. It is not a scatter plot. You must connect the dots.
Okay, while we're editing, you need to label too.
That's where I was going next. No, you don't have to label it. I will tell you this. One of the questions is going to ask you to draw lines through the noble gases. So you might want to label the noble gases as you go there, because that might make it a little easier on you. Okay? No. Now, questions about how to draw a graph. Now, once you've got that done, answer the questions. If you need to attach a page for a question, that's fine. I prefer the questions to be answered on the paper, though. Okay?
So, I'm making sure our no guys are gonna be, you know what, I'll let you do it. Never mind, I got it.
Okay. I think that's fabulous. Like I told you, I'm appalled at sometimes my own dog. If you need to do makeup work, I will be here this afternoon. If you need to make up the test, if you cannot do it today, I will be here Monday, and that is it before break for the test. I am not staying next Tuesday. You'll be a speed bump on the way out of the parking lot. What?
Because I told him I'm gonna beat him up.
I don't even want to stay on Monday, but I guess I am.
That was all.
You know, I see you more than I did when you were in my classroom.
I came to school every day.
Every morning, you come to twice a week.
You know, you're cheerier than you were when you were in my class. Better behave too, I might add.
She doesn't ever talk to me.
Just saying.
Look, don't touch me.